This is a Commodore SFD 1001 disk drive. It might look like a 1541, but in fact it's actually a PET era IEEE 488 parallel drive. That makes it a lot faster than a 1541, but we can't actually use it on, say, a C64 or a 128 because it needs that parallel interface. Although we can actually get a parallel interface or build a parallel interface to use it, but it will work with the mini PET that's on the shelf behind me. Not only is the SFD faster than a 1541, but it can actually store more information. A 1541 can hold 170K on one side of a 5¼ inch floppy disk. The SFD will hold 500K on the same side of a disk. And not only that, the SFD is a double-sided drive, so it can hold a whopping 1 megabyte on a disk like this. There's something else about this particular drive that I didn't know when I bought it. It's got a sticker on the side that says it's property of Precision Software. If I turn it round, Precision Software were the makers of Superbase, Superscript, EasyScript on 8-bit computers. And in the late 1980s and early to mid 1990s, I actually worked for the company. So it's entirely possible that while this drive was being used, I came into contact with it. And now I have it again. The first thing you notice about this drive is its weight. It is heavy. So, out of curiosity, let's just weigh it. 4660 grams. So this is by far the heaviest drive that I think I've seen. Now, the back, this is why I haven't taken it apart before. The back shows the power to be 117 volts AC. And of course here in the UK we are at 230 volts. So I'm not plugging it in. But also you might notice that the power connector and the IEEE port shows some kind of rust. So I haven't opened this up before, so I don't know what it's going to be like inside, but that's definitely cause for concern. I'd like to thank my sponsor for this video, PCBWay. PCBWay is currently running its 8th anniversary promotion with tons of coupons and massive discounts and much more. So now is the perfect time to get high quality prototype PCBs or production PCBs or project PCBs like this or like this. They also do CNC machining, 3D printing, sheet metal fabrication, injection molding and much more. Prices start from just $5, and with super quick delivery options you'll have your PCBs in a jiffy. So if you have any kinds of PCB or prototyping requirements, why not give PCBWay a try? The link is in the description below. And now back to the video. Okay, the moment of truth. Let's turn it over and open it up. And 4. Now I'm expecting to see a big old heavy power supply and something that looks like a 1541 drive. Okay, the inside of the plastic case looks fairly clean. That's a long board. This is presumably the power regulators. That's going to go to the drive, or that's going to go to the drive. That probably comes from the transformer. So, what have we got? 6502, 6522, 6532. I'll just dry wipe it for now. So I think that must be some sort of ROM. That's some kind of daughter board. I can't tell what that chip is. That's interesting. I'm going to have to do some studying on what's on this board and its layout and so on. I do know that this is basically half of an 8250. Let's see what's underneath. Let's take this board off. That screw is just holding the daughter board onto the main board. Okay, that's the LED connector. I presume that's the LED connector. It's a bit big. This is the power. Fold that out and fold that down. Okay, there are some bodge wires on the bottom, and that there has had some work, which is that chip there. Now that's interesting. So that does appear to be heat sinks for the power supply, which is all this stuff here. Now on a 1541 these voltage regulators are on the main PCB, but it looks like we might just be getting the 5 volts, I guess, and ground. And that might be, this might be the 12 volt supply going into, could it be? This is just speculation and I'll have to have a look. But maybe that's 12 volts. It goes into the drive circuitry, and this is the 5 volts that drives the TTL. But there's none of the gate arrays and stuff that we would see on more modern drives. And the drive, so the heads are underneath this. So I think we're going to have to take it out before we can clean it. I'm not quite sure. Okay, research time. See you later, alligator, in a while, crocodile. I've taken the cables off. These are actually keyed. So, and this one. So there's a pin missing, and so we can't put those back in the wrong way around. I'm speculating at the moment, but maybe this has got 12 volts on it, and maybe this has got 12 volts on it, and maybe this has got 5 volts on it. We shall see. Now I have got in stock a spare connector to go on here, although it doesn't have these screw-in terminals. Maybe we can resurrect those. So let's take this off and look underneath. Okay, there appears to be one large tray. This is probably why it's so heavy, and everything is screwed to it. Let's see if we can take that out. Six screws. Let's see if it will lift out. Oh, one thing I noticed about this main board, if you look carefully, you'll see there are actually two 6502s. So this is a dual processor system. Very interesting. Might need to get a new mains plug socket because that looks a little bit manky. underneath, that's the drive. So coming off the power supply, black and red and yellow and grey. Yep. This yellow and grey to the front comes off from here. Yellow is marked plus and grey is marked G. This cable, which went to the this socket here, that is the LED cable that goes all the way to the front. So that is this cable here. So we've got basically two supply voltages. We've got 5 volts and we've got 12 volts. And I think that's going to make it relatively easy, straightforward, to replace the power supply. 2 big screws, 4 big screws there, and the regulator board. And these are the voltage regulators. I'm gradually learning my way around this drive. Now, I think I want to take the transformer out because we won't know whether it's 110 volts or 240 volts until we can look at the input connections, and hopefully they're labelled. I've got another one of these main sockets on order. That won't come for a couple of days. But if I can put a mean well in, that's going to give us a guaranteed power supply. This is a RD50A, which is the usual 5 volts and 12 volts. This is a higher current output than the RD35A. The 35 would probably be okay for the 5 volts, but the current draw on this is 1.25 amps at startup, and the 35A only delivers 1 amp on the 12 volts. So we really do need to go to this one just for the extra added overhead. Now, one of the things that I've read about this drive is that the motor board, the drive itself, and this is the motor board, you can see it through here, is prone to capacitor leakage. So we're going to have to take the drive off and have a look at that. I can't really see, just looking through the chassis, whether it's leaked or not. That is apparently quite a common failure, so we will need to look at that. And I think we need to take this out. So let's undo these screws. Okay, the transformer is just plugged in to the rectifier board. As I did with the 1571, I can probably just replace the wiring and keep the switches and the fuse holder in place. That was just held on with adhesive thermal paste. Okay, I'm going to cut these off because we're not going to reuse them. Now, how do we take the drive off? Okay, the drive has 4 screws that go through the side. Let's look at it on the underside. Oh yes, you can see some corrosion damage here. The capacitor is going to need to be changed. Now I have some instructions for getting this board off. I won't do it just now. I'll make sure that I've got the capacitors ordered so that we have some replacements to put in. Meanwhile, I shall put these screws back in the holes so they don't get lost. Let's do some cleaning. Now I want to clean the drive heads, but to get to the drive heads we need to remove this cover. So I think there's two screws, that one there and this one here. So I'm using a different screwdriver because this one is not supposed to be not magnetic. Let's take that out. This is kind of thin, so because it's so thin the drive door doesn't close properly with it inserted. It's hard to see in there, but it doesn't look on the face of it very dirty, but we don't know. So some IPA on cotton bud. Stick that in there and clean. That should clean the top surface and the bottom surface at the same time. Oh, there's definitely some dirt. Squeaky clean, that's on the bottom head. I suppose that makes sense that the bottom head would be dirtier. Still coming up with dirt. You need to be very careful when lifting the top head because that's going to be a fragile mechanism. I think that's clean. Now I want to look at the various rods. So when the head moves, it does move. It seems to stick a little bit, and there's these two rods down here which need cleaning. And the sound recorder has run out of batteries. There we go. I've put some very tiny amount of silicone grease in this tray so I can lubricate this rail. Right, let's take a look at this board. Now we need to take this plate off. Of course that's hard to lift off because it's a big magnet. And then we need to lift this circuit board. There are instructions for doing this on the World of Janny website. I'll put a link to in the description. There's two connectors on this PCB, here and here, that need to be desoldered before we can take the board off. So let's get the gun. It does not want to unsolder. Let's try a traditional soldering iron. There we go. Okay, so this is the motor board. Here's the area of corrosion, so these are the capacitors that have leaked. Anyhow, the replacements will be here in a day or so we can recap the board. Looking on the top of the drive, there are two screws here and here which are holding the front plate on, so we can take those out and then we can clean the front. I think this is probably just levers off. That looks horrible. It's clearly been kept in some sort of unpleasant environment. Okay, that's kind of manky, so it looks like we need to clean that up. Obviously been in some not very pleasant environment. Right, cleaning will be underway. Now we come back to the motorboard. I've got the capacitors that we need. The only issue is that two of them, these ones, are physically the wrong size. They're too big, and so I think I'm going to have to try and fold them over. But we shall see. The first thing I'm going to do is take these. I've made a little diagram of where everything goes in the polarities of it. Those three are not polarized, but these other ones are. I've made a note of the polarity of them and the positions on the board and the values. And these three I'm going to tackle first because this is where the board is not dirtiest, most corroded. The second patch of corrosion is down here, which is by this one, C12, that's 33 microfarads. Now, the legs actually go that way, so if I'm going to bend them over, I'm going to have to bend them over like that, which is going to be kind of awkward because there's going to be one long dangly leg. It could work. This solder looks like it's going to be particularly crusty, so I think what I'm going to have to do is add some new solder as well as some flux. Okay, so that's cleaned back to bare metal. So now what we want to do is tin that. Right, that didn't go quite as smoothly as I'd hoped. We've lost a trace between there and there, and this hole is going to need careful folding over of the leg. But Captain Bodge Wire will live again. Let's put these new caps in. So 22 microfarads, negative up. Okay, the second one goes, this is 22 microfarads, and the third one, which is 4.7 microfarads, and the opposite way round, goes in here. For the bodge wire, I'm going to use an offcut of one of the capacitor legs and hold it down onto the board with a piece of Kapton tape. connected to that. Okay, so that's done. We need to lacquer that over later. Okay, the next one we will do is this one, C17, because it is the same value as we've already used. It's 4.7. There's no corrosion on the board at this point, so that's okay. Now C10 is 47. There we go, so once again we need to scrape this off. And these three, slightly bigger, they should fit. These are actually glued down, so we're going to need to break the glue off. Now these are bipolar, which means that there isn't a positive and negative side, and they can go in either way round. We'll hold them down with a bit of Captain tape. But because I didn't hold the board where the camera was looking, you'll have to take my word for that. Now these last two are, as you can see, the wrong size, so that's not going to fit, and they go that way around, so I think we're going to have to bend them over like that. And that's two. So now we come to fit the motor board back into the drive assembly. So we need to reattach this. I'm sorry, I need to see it so the camera might not pick it up, because this one is fiddly. Right. Solder them quick before they get away. So the board is back in. Okay, so 4 screws for the board. This was the long one. This is going to be tricky. That's not right at all, is it? I think this is actually underneath. Right, so I need to take this all off again. Good here, isn't it? Right. Okay, that's gone in. Now we can put it back together again. Okay, now I'm not going to nail varnish over these little bits because I've got some special PCB lacquer coming that hopefully will do a better job. There we go, one drive put back together, and if this works it will be amazing. Hi, Editing Tim here. I'm cutting the video short at this point, so to see the rest of it then come back next week and make sure that you click on the subscribe button to get notified of when the video comes out. Meanwhile, have a look at that. See ya. Bye.